Hi, you guys. I'm going to do Chapter 5, Semester 1, Final Exam Review. Yep, got all the words. Okay, let's go. I ask that you pause it and you do the work and then you start to check that it's correct. Just writing the answers will not help you on the final exam. So here we go. First triangle, FGH is equilateral, equal sides, meaning all sides are equal. And it gives us the lengths of each side. So I have triangle FGH, all the sides are equal. I'm going to write in the expressions for each. Now, because all the sides are equal, I can set any two sides equal. It doesn't matter which sides I pick. Because they're all equal, I could just set two of them equal. You could do all three, but it's kind of hard. I wouldn't do that. So this is a side equals side, part equals part problem. I'm going to pick, again, it doesn't matter which two you pick. Because they're equal, you will get the same answer for all of them. Okay? It says, find x and find the measure of each side. So if I take that 7 and I substitute it in, I'm looking for another color pen. Okay, here's red. So I've got the 7 right here, right? So I could take 7 and plug it in. If I put it right here, right? So I've got 7 plus 5, that gives me 12. If I did it right, all three sides should be 12. 2x minus 2, this means multiply, mashed is multiply. 2 times 7 minus 2, 14 minus 2, yep, 12, did it right. Okay, I could plug it here. 3 times 7, right, minus 9, 21 minus 9, and yes, it's 12. So we did it right because all three sides came out to be the same length. Now, isosceles triangle means at least two sides are congruent, but in all the work that we do, it's only two sides are equal. So two sides have equal length. I'm just going to draw the triangle. I've got triangle LMN, and I'm just writing them in any order. It doesn't say. And it says length LM, L to M, is the same as length L to N. Wait, L to M and L to N. Your picture may look different, which is okay. It doesn't matter. It says from L to M is 3x subtract 2. From L to N is 2x plus 1. And these are the two sides that are equal. This one is here only to trick you. This length has nothing to do with these two sides being equal. This is a distractor, okay? Two sides are equal, so I'm going to have a part equals a part, side equals side. Write your equation, solve your equation, get all the x's, get rid of one of the x terms, right? Now I'm going to go back to the question. Okay, in the directions above, it says for numbers 1 and 2, draw and label the triangle, find x, find the measure of each side. So this 3 then, I would substitute back in here. So I'm going to do it again in red. So it's easy to see. This is times 3. 3 times 3 minus 2. 9 minus 2 is 7. If I did this correctly, I should get the same for length LN. I should also get 7. So 2 times x means 2 times 3 plus 1, and 6 plus 1 is 7. Okay, that's good. Down here, it says 5x minus 2. So 5 times 3 minus 2. 15 minus 2 is 13, which is okay. That's fine. We're allowed to do that. Okay. Now, in this triangle here, it says find the measure of each numbered angle. Well, whenever you have perpendicular lines, that means the angles are 90 degrees. I know this total is 180. So I've got 180 degrees. I used up 90, so that means this other side is also 90. If one of the angles is 90, all four are 90. So angle 2 is 90 degrees. Now I'm going to take this triangle and I'm going to draw it a little bit bigger. So I'm going to work with this triangle right here, okay, that one, so that you can see it better. We said that 72 was given. We know this is 90. The sum of the measures of the interior angles are always 180. So this doesn't mean 1 degree. It means angle 1. So I know when I add all the angles together, it always has to be 180 for a triangle. So I've got 72 degrees plus 90 degrees plus this measure of angle 1. You could just call it x if you want. Add your like terms together, and I wouldn't put the degrees in there because it just gets too tricky. So you're going to get 162. Now subtract your 162. Okay, you get 18 degrees for measure of angle 1. Okay, this looks like, I don't know, a grassy field or something. So I've got 40 degrees here, 55 is here. What's angle 1? Again, the sum of the interior measures of a triangle are always 180. It's your golden rule. So this time we're going measure of angle 1. It's still the same. Angle plus angle plus angle for a triangle is always golden rule, 180. That's supposed to be an angle symbol, not an L. Measure of angle 1 plus 40 plus 55 is 180. Go ahead, add your like terms. We want to solve. If you just call that x, that's absolutely fine. And there you go for measure of angle 1. Now we want to do this triangle also. I can look at, you got 2 different triangles here, and it's just tricky because they're hooked together. Just look at one at a time. This one's not hard if you just do one at a time. I'm going to do the pink triangle. You guys, it's the same thing. The sum of the angles is 180, and you guys know now that this is 90, so I'm going to go 58 plus 90 plus angle 2. So 58 degrees plus 90 degrees plus the measure of angle 2. You could just call that x if you want. Add your like terms together. And then go ahead. Remember, this is a plus here. If there's nothing in front of it, it is always a plus. Sorry, that's minus 148. Got sloppy. For 32 degrees. Okay, so that's measure of angle 2 is 32. Now I'm going to look at the other triangle. I'll do it in yellow. This one. Okay. Right? So this one here, I did in yellow for us. We're doing the same thing. We've got a 90-degree angle. This time I'm going 64 plus 90 plus measure of angle 1 equals 180. Add those. What is that, 26? Okay. And that's all you got for that one. Okay, hold on a second. Oh, geez. So those two. Look it over. We're doing good. Okay, all this, if you guys, I should have said this in the beginning. Everything in this is about triangles. So we're doing the 180 degrees. We're talking about isosceles, equilateral, which remember, if it's equilateral, it is also always equal angular. And when that's true, that means the measure of each angle is always 60. Okay, those are big things. And then we're going to prove triangles are congruent. You got side, 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 angle, side, angle, side, angle. What else I got? HL. You can't do angle, side, side, right? Can't do that one. What am I missing? I'm missing one. Side, angle, side. No, angle, side, angle. Angle, angle, side. Okay, and angle, angle, side. Those are different ways to prove triangles are congruent. That's this whole chapter. Okay, so now over here, oh yeah, I forgot. If two polygons are congruent, okay, that means all the corresponding parts are congruent. The corresponding angles are congruent, and the corresponding sides are congruent, okay? So everything that matches, corresponding means matching, okay? So for instance, angle A corresponds to angle P. So on this right here, A and P go together. It's kind of nice when you write them under each other because it's easier to see and you can't crisscross them. So angles A and P to go together. So this is angle A. That means it has to be congruent to angle P. So that means 2x plus 4 is 100 equals 100. Go ahead. Right, and you get 48. So x is equal to 48 degrees. Or just 48, yeah, 48 degrees. And on this one, it just says find the value of x. Now we're doing this other one for y, so I know side DC, but over here I've got two numbers, 12 and a 10. So what does DC, that length, match up with, right? So DC is the last two letters, so it has to go with the last two letters, RS. DC matches up with RS. So that means then that I'm using length RS, the 12. So we're doing the same, write your equation. You're using corresponding sides. This is a congruent statement, and it's always written so the orders are the same. Okay, there you go. Now, numbers 9, 10, 11, we're proving triangles are congruent, okay? Again, it's side, 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 angle, side, angle, side, angle, 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 side, HL, hypotenuse leg, and we cannot do angle, side, side, okay? You're going to write down given statements, and you know the givens because you have curves for angles and hash marks for sides. So we're going to write all of our givens here. I've got angle J and angle L are congruent. They both have the two curves. That's when you have the curves, right, which is the given. The picture is telling me, it's giving me that that is true. Now, angle L only has, or J only has one angle here. Angle L only has one angle at the vertex. I can use just one letter. But now I want to say that this angle, right, is congruent to this angle. And in order to do that, there's more than one angle at the vertex, so you have to walk and talk the angle. You have to use three letters. It's either one letter or three letters. So I'm going to start here. Angle J, M, K is congruent to, that has the same measurement as angle L, K, M. Now look again, okay? Oh, I've got M, I'm going J, M, K. M is my middle letter because that's the vertex. Vertex is always on the middle. L, K, M, L, KM, K is in the middle, it's a vertex. Again, we know this is true because of the curves. That statement is given to me. It's telling me it's true. Other things to look for in the diagram that aren't necessarily given to me, we have lots of, I'm going to write down here, look for vertical angles being congruent. Look for a shared side, which is, oh my goodness, shared side, which is a reflexive property. Those are two big ones. You might see bisect in there as well. Okay, so we're going to do this. We've got this shared side, which is side KM, is congruent to itself. That's a shared side. That's a Lipinski idiom. It's really called the reflexive property. Now, we have to write the triangle in order. I'm going to start with the 2 marks to the 1 mark to the no mark. Triangle JMK is congruent. So I'm going to go 2 marks, 2 curves, 1 curve, no curve. LKM. And look what we did. I didn't mark the shared side, right? Right, here's the shared side. We did angle, angle, side. If it were this side between the angles, you would say angle, side, angle, but it's not. It's angle, angle, side. Okay, there's your first one. Second one, let's mark down everything that has the hash marks. Side FG is congruent to side GH. That's your hash marks, which means it's given to us. They're telling us, whoever wrote the question, in this case, like if the book wrote it, whatever, a standardized test, but this is given to me, and I know it's true because of the hash marks. The real official word is given, okay? I've got these 2 down here. I've got 2 hash marks. 2 hash marks. You have to go start to end, start to end. You always have to have a starting and an ending place when you're naming a side. Okay? Segment FI, segment IH. Why do I know? Again, the hash marks tell me so, which is given. Now I look at this and go, geez, I always have to have 3 things unless it's a right triangle. This is not a right triangle. In that case, you could do hypotenuse leg, but that's not this. I've got the shared side right here. Shared side. So I'm going to, that by reflexive property, when I split these up, right, this side here is part of each of those triangles, the left triangle and the right triangle. So that's a shared side. That's reflexive property. Side GI is congruent to side GI, and that is shared side. But remember, that's just my word. The real word is called reflexive property. Remember, when we say reflexive, it sounds like reflection because you see yourself in the mirror and you're equal to yourself, but it's really reflexive. Okay? Now look what I got. Side, side, side. There's no angles in here. I got 2 set triangles are congruent to each other. And these, I'm going to go GFI, GHI. Okay, those are my 2 triangles congruent. Okay, last one. Okay, same thing. Let's list what's given to me in the diagram. I've got length BC is congruent to length CE. The hash marks again, 1 mark, 1 mark. That's my given. I'm going to do the 2 marks, 2 hash marks. Beginning to end, beginning to end. So I've got 2 sides. Now I'm going to use my vertical angles. Remember, when we do vertical angles, it's these opposite angles. That angle is congruent to that angle. We also know that the top angle and bottom angle, you always have 2 pairs of congruent angles. So right here, it's 2 intersecting lines, right? So that means this angle here is congruent to this angle here. Those are vertical angles are congruent. Again, I can't call it angle C because there are more than one angles at angle C. So I'm going to walk and talk, use 3 letters. The middle letter has to be the vertex, which is the turning point. Angle BCA is congruent to angle DCE. Vertical angles congruent, okay, or just say vertical angles. Let's say triangle BCA. Now, you gotta be careful on this one. Okay, triangle BCA. So I'm going through the 1 hash mark to the 2 hash marks. So I cannot, this does not reflect straight over. It does not. This side here, BC, is congruent to side CE. So instead of BCA, I'm going to go ECD. And my reason on this one is side included angle, right? It's included. It's the angle formed by these 2 sides. So it's going to be side, angle, side. Okay. That is Chapter 5 review. You guys are done. If you go ahead and do Chapter 6, that is extra credit. And I am not making video for that one.